Welcome to this video on software engineering for EOT. In this video, we will explore the basics of software engineering for EOT, its importance, and the challenges that come with it. EOT, or the Internet of Things, is a network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, and connectivity. These devices collect and exchange data with each other and with the cloud, making our lives easier and more efficient. However, the complexity of EOT systems and the large amount of data generated by them pose significant challenges for software engineers. To ensure that EOT systems are reliable, secure, and scalable, software engineering principles must be applied to their design, development, and maintenance. The importance of software engineering for EOT cannot be overstated. Poorly designed or implemented EOT systems can lead to security breaches, system failures, and even physical harm. Therefore, it is essential to follow best practices in software engineering to ensure the safety and reliability of EOT systems. In the next segment, we will explore the software engineering process for EOT systems. The software engineering process for EOT systems follows the same basic principles as traditional software engineering, but with some additional considerations. The first step in the software engineering process for EOT systems is requirements gathering. This involves identifying the needs and goals of the system, as well as the constraints and limitations of the hardware and software components. Once the requirements are defined, the next step is system design. This involves creating a high-level architecture for the system, including the hardware and software components, data flow, and communication protocols. The third step is implementation, where the software and hardware components are developed and integrated into the system. This involves writing code, configuring hardware, and testing the system to ensure that it meets the requirements. The fourth step is testing and validation, where the system is tested to ensure that it is reliable, secure, and scalable. This involves testing the system under different conditions, such as high traffic, low connectivity, and security threats. The final step is maintenance and updates, where the system is monitored and updated to ensure that it continues to meet the requirements and remains secure and reliable. In the next segment, we will explore the challenges of software engineering for EOT systems. Software engineering for EOT systems presents several challenges that are not present in traditional software engineering. One of the main challenges is the heterogeneity of EOT systems. EOT systems consist of a wide range of devices with different hardware, software, and communication protocols. This makes it difficult to develop software that can run on all devices and communicate with each other seamlessly. Another challenge is the limited resources of EOT devices. Many EOT devices have limited processing power, memory, and battery life. This makes it challenging to develop software that can run efficiently on these devices while still providing the required functionality. Security is also a significant challenge in software engineering for EOT systems. EOT devices are often connected to the Internet, making them vulnerable to cyber attacks. Ensuring the security of EOT systems requires implementing strong encryption, authentication, and access control mechanisms. Scalability is another challenge in software engineering for EOT systems. As the number of devices in an EOT system grows, the system must be able to handle the increased traffic and data volume. This requires designing the system to be scalable and implementing load balancing and other techniques to ensure that the system can handle the increased load. In the next segment, we will explore the best practices for software engineering for EOT systems. To overcome the challenges of software engineering for EOT systems, several best practices should be followed. The first best practice is to use standard communication protocols. Standard protocols such as MQTT, CoAP, and HTTP can be used to ensure that devices can communicate with each other seamlessly. The second best practice is to use lightweight software frameworks. Lightweight frameworks such as Node-RED, Mosquitto, and Eclipse can be used to develop software that can run efficiently on EOT devices. The third best practice is to implement strong security measures. This includes using strong encryption, authentication, and access control mechanisms to ensure that EOT systems are secure. The fourth best practice is to design for scalability. This involves designing the system to be scalable from the outset and implementing load balancing and other techniques to ensure that the system can handle increased traffic and data volume. The fifth best practice is to follow an agile development process. Agile development allows for rapid iteration and testing, which is essential for developing software for EOT systems. Finally, it is essential to involve all stakeholders in the software engineering process, including hardware manufacturers, software developers, and end users. This ensures that the system meets the needs of all stakeholders and is reliable, secure, and scalable. In the final segment, we will summarize the key points of this video on software engineering for EOT. In this video, we have explored the basics of software engineering for EOT, its importance, and the challenges that come with it. We discussed the software engineering process for EOT systems, which includes requirements gathering, system design, implementation, testing and validation, and maintenance and updates. We also explored the challenges of software engineering for EOT systems, including the heterogeneity of devices, limited resources, security, and scalability. To overcome these challenges, we discussed several best practices for software engineering for EOT systems, including using standard communication protocols, lightweight software frameworks, strong security measures, designing for scalability, following an agile development process, and involving all stakeholders. In conclusion, software engineering for EOT systems is essential for ensuring the reliability, security, and scalability of these systems. By following best practices and involving all stakeholders, we can develop software that meets the needs of all stakeholders and ensures the safety and efficiency of EOT systems. Thank you for watching this video on software engineering for EOT.